Not bad. Okay, now this is when the numerators are not constant. What does that mean? That means when we do our numerators after we factor everything, it's not going to just be just A, B, and C. Now, let me show you for a second. They're going to be linear. And linear just means there's going to be one x in there, and the x has to have a degree of 1. All right, now this is proper because the degree on top is bigger than the degree on the bottom, so that means we don't have to divide it, but we can factor this. We can take an x out, and we would get an x squared plus 4. Can we factor it anymore?
Yes.
No, we can't. I tricked you. You see this? This almost looks like a difference of squares. That is not a difference of squares. That means you cannot factor it. You can't factor it. You can't find two numbers that give you this, that multiply to give you that. You can't do it. Not possible. It is not possible. If that was, if this was the quadratic that you had to solve, you would have had to use the quadratic formula because you can't solve it. You can't factor it. I mean, you can solve it, but you can't factor it. Where's the C? What are you talking about? The quadratic? Oh, the C would be, for the quadratic formula, it would be, the A would be 1, the B would be 0, and the C would be 4. Okay, so this is what your answer is going to look like. You're going to have 3x squared plus 4x plus 4 over the factor denominator here. And then, you know, when we split it apart, it's going to look like this. There's going to be 2. One of them's going to have an x, one of them's going to have an x squared plus 4. And because the x is squared inside the factor, like I'm saying like this whole thing is the factor, because the x is squared inside the factor and not like this, then we don't have to do it twice like what we were doing before. If it was x plus 2 squared like that, then when you split it up, you would go x plus 2 plus x plus 2 squared, and that's how you do the partial fraction decomposition. That's what you would do if the squared was doing it to the whole factor. But in this case, the squared is only doing it to the x. And so that means we have something weird, and that's called a linear numerator. So I used the B and the C just because those are numbers that we're looking for. The x is going to remain our variable. The B and the C, you guys remember like things like this, like 2x plus 1. This is a linear function, right? It'll give you a straight line. Why? Because it has an x and the degree of the x is 1. That means you can call it linear. So we have a linear factor here. And don't ask me why. Besides the fact, you know, because you guys didn't ask me when I put an A up there. You just go, oh, I could put an A right there. Well, you put a bx plus c, you put a linear numerator right here when the x inside the factor is being squared. And then you get busy with it. Just like before, we have to multiply everything by the common denominator. So my common denominator in this case is going to be x times x squared plus 4. So, for the first one, the whole denominator cancels out. So I'm left with 3x squared plus 4x plus 4 equals, for this, when I multiply it times this fraction right there, I'm going to cancel out that x, and I'll be left with a multiplying to x squared plus 4. Now this one, let's see, it's going to be bx plus c, and what are we going to multiply it by? Well, when we multiply this times this, the x squared plus 4 cancels out, right? And so we're left with an x. We only have to multiply it times x. And this one has a different approach. Before, what we did is we would pick x's that would work in our favor. They would eliminate other variables so that we can find what we're looking for. In this case, we're not going to do it like that. We're not going to pick x numbers. Instead, what we're going to do is we're going to try to match this side to this side. So we're going to try to make them look like each other. In order to do that, we're going to first have to distribute everything over here and simplify this side. So we get ax squared plus 4 times a. I just distributed the a. And then I'm going to go and distribute the x. Oops, right there. So it's going to be b times x squared plus c times x. The next thing we got to do to try to make it look like this side is combine like terms. Now, our first term right here is the x squared term. Over here we have two x squared terms. So we're going to do what you normally do. If this a was a 5 and this was a 2, what would you do? You'd just go 5 plus 2, right? Then you would have 7x squareds. But here, we don't have those numbers, so we have to write a plus b x squared. And you put the parentheses around it, because whatever this number is, you're just going to multiply it to the x. And you have to add those up first before you multiply. So those are my x squared terms. And now what's my x term? Oh, just cx. Okay. And my constant? Yeah. It's 4a. I'm going to write a. Yeah, let's just write 4a. I don't like to write a times 4, but let's write 4a. Okay. Now the other side, that's your 3x squared plus 4x. Whoops, that's an ugly 4. Plus 4x plus 4. Okay, so now we have to match things up. Like this and this, because they're both x squared. So it'll be 3x squared equals a plus b x squared. And if we go to solve this one, we divide both sides by x squared, and so they both cancel out. And I'm left with 3 equals a plus b. And I'm stuck. I can't solve it now. So let's look at the next one. The next one are the x terms. And so we have 4x equals cx. Divide both sides by x. They both cancel out, just like the x squareds before. We have c equals 4. Yay. And then to find the last one, we're going to take the constant and set that equal to 4a. So we have 4 equals 4a. What does a equal? Uno. Now, can we solve this guy? Yes, we're going to plug 1 into the a. Now, what would b equal?
2.
B would equal 2. So now you just got to take your a, b, and your c and go back up to where you were before when you originally split it up and plug in your numbers. Okay, we got 1 for the, no, not for you. We have 1 for the a. And what's my b?
2.
My b is 2. What color was that one? Green? So 2. And then the last one, c is a 4. And so this is your answer right here.